I'm Rosemary Bartlett with the Pacific Northwest National Laboratory, and I'd like to welcome you to today's webcast, Advanced Energy Design Guide Recommendations, Mechanical Overview, the second in our three-part series on the AEDGs, brought to you by the U.S. Department of Energy's Building Energy Codes program. For those of you wanting continuing education credit for the event today, a link will be provided at the end of the webcast. AIA members should write down the link and go to that link and provide us with their names and AIA membership numbers, and we will submit the information to AIA for their credit. In addition, anyone wanting a certificate of completion to self-report to a professional organization should write down the link to go and generate and print one. We're very happy to have as our speakers today Paul Torcellini and Shanti Pless with the National Renewable Energy Laboratory. Welcome to both gentlemen. And Paul, please begin.
Today we are going to be talking about the Advanced Energy Design Guides, in particular the HVAC recommendations. I am Paul Torcellini, and with me today is Shanti Pless.
Hello, I'm an engineer here at the National Renewable Energy Lab, and welcome.
So Shanti and I, along with others, have been heavily involved in the Advanced Energy Design Guides. That is an effort of several organizations, including AIA, ASHRAE, the U.S. Green Building Council, and the Illuminating Engineering Society, sponsored in part by the U.S. Department of Energy. There are currently 4 design guides that have been published, including the Small Office Guide, the Small Retail Guide, the K-12 School Buildings Guide, and just recently the Warehouse Guide. Between these 4 that have been published, more than 100,000 guides have been distributed. In fact, if you looked at these guides in total, if every guide downloaded resulted in a single building designed to save 30% beyond the code, the estimated energy savings would be 52 trillion BTUs and over 9 million tons of carbon dioxide. If you translate that, that is about $600 million of energy savings. The guides can be downloaded from the ASHRAE website. The URL was listed on the first slide, and here is an example of what that website looks like. You can also get to it from the ASHRAE website, and as indicated, it is a free download to get the ASHRAE design guides. I've already mentioned that it is a collaborative of partner organizations, and it is really a committee effort. Management by a steering committee and a group of volunteers put these guides together over the course of a year. Those guides had experts related to each of these specific areas, and within those areas we had experts related to lighting, envelope, and mechanical systems. In addition, a focus group was used for conceptual review to make sure that the direction of the guides was appropriate and could be readily adopted by the industry. Finally, a 65 and 90% public review was done of the guides to solicit input to make sure that the guides were correct technically and other errors were picked up before publication. Now, what is the goal of these guides? Really, they are packages of recommendations that result in a 30% energy savings when compared to the code ASHRAE 90.1 in 1999. It represents a prescriptive measure based on different climates, but we have to remember that it provides a way or some ways, but not the only way to build energy efficient buildings. What we were striving for was to pre-compute a set of solutions that people could readily adopt with existing technologies and get to 30%. It is not a code or a standard, nor is it written in that type of enforceable language, but it is truly a guide to get a 30% progress towards a net zero energy building. The guide contains an introduction. That introduction is specific to each of the different audiences that the individual guides are intended for. It has a process for achieving energy saving, really how to do these different things from an integrated process. And then in Chapter 3 are recommendations by climate zone, realizing that different climate zones have different energy solutions to get to that energy savings, and we'll talk more about that later, in particular with the HVAC. Because a lot of architects and engineers as well as building owners want to see that this has been done before, there are technology examples and case studies in the guide to show people that it has been done. And finally, there's a how-to section that, based on the recommendations, people want to know how to do different details and some pitfalls to avoid and some things that have worked well. Those recommendations are listed in Chapter 5, and they're divided between quality assurance, envelope, lighting, HVAC, service water heating, and then there's a bonus savings section. If you want to get above 30%, some other areas where it is possible to save energy in a very practical way. We're going to focus on the HVAC section today. The development of the recommendations were done for envelope lighting, HVAC, and service hot water heating. And when all of these things are put together and all the recommendations are followed for the climate, it is expected that at least a 30% whole building energy savings will result. Energy was the independent variable, and cost effectiveness, e.g. payback, is the dependent variable. The recommendations were modeled to verify the 30% savings over ASHRAE 90.1, 1999 in each climate zone. So really, simulation helps to guide the solutions, as well as verifying that these solutions did make sense over a series of test sittings. These looked at the energy savings was based on site energy use. It also included typical plug loads that is part of the whole savings. As far as the development of the recommendations under HVAC, we strive to use practical off-the-shelf technologies and strategies that were available from multiple manufacturers. We did not want to recommend something that was very unique or something that has not been well tried. We also provide climate-specific HVAC recommendations for typical system types. So the HVAC recommendation types include heating and cooling system types, heating and cooling efficiency, ventilation control and preconditioning, whether economizers are recommended, fan efficiency, and there is some discussion about duct design. We were really striving to get a whole picture integrated approach to delivering heating, cooling, and ventilation to the space. So as far as the climate zones, we use the DOE climate map, and that is divided into 8 climate zones as shown on the slide. The recommendations for each of those climate zones are contained in a single table in the guide by these different climate zones. Notice that there is also divisions not only by temperature, but also by whether the climate is moist, dry, or a marine climate. We also did the modeling in these cities to verify the energy savings. So Shanti, do you want to lead us through some of the information on the recommendation table?
Sure. So this is an example of one of the recommendation tables for Climate Zone 4, and it shows all the table structure that each of the guides contain. So there's a general envelope recommendation section, which will be covered in a later webinar. The next part of this table includes lighting recommendations, which we've already had a webinar on, and we'll focus on the HVAC recommendations. You can see here there's HVAC system types with their related efficiencies based on SEER, EER, integrated part load, or for the furnace, annual fuel utilization efficiency or thermal efficiency, heat pump efficiencies, and then whether or not an economizer is recommended, how the ventilation is controlled, and then ductwork design. So we'll continue to talk about those elements of each of the design guides. This is just an example of how the guides, the tables look in each of the guides.
I'll also note that on the right-hand column, usually starting with a letter, so in our case HV, are the how-to tips that are referenced in a later chapter. So you can pick the line that applies to the type of HVAC system you have, and you can get a cross-reference to different how-to tips. Now, as far as integrated design concepts in HVAC, there's some other pieces. Really, you should think about the HVAC last. And think of the HVAC as really meeting the heating, cooling, and lighting loads, well, actually just the heating and cooling loads and ventilation loads of the building that cannot be met by the envelope. And so if you want to reduce the loads, then we first need to look at siting and orientation, the glazing, the envelope, the lighting and daylighting, as well as the plug loads. Then you want to design the HVAC system to meet any remaining loads. So notice that it is last in the list in terms of the design guidance. The Advanced Energy Design Guides also provide a chapter to help implement this concept. As far as the guides go on before that have been published, the office guide includes buildings up to 20,000 square feet. Likewise, the retail building is for that same scale. So really the concentration was on buildings that normally would not have a lot of simulation or necessarily expertise to put them together. So that kind of goes back to having recommendations that can be easily implemented by a wide audience. The K-12 school guide actually included buildings that were a little bit larger than that, and was also divided into elementary, middle, and high schools, realizing that there are different programmatic needs. We're going to spend some more time on the HVAC for the K-12 because it also was much more complicated than the other advanced energy design guides. The warehousing, because it's a very homogeneous type of building, includes buildings up to 50,000 square feet. For each of these types of buildings, the HVAC recommendations were based on typical system types.
So if you look at, for example, the small office design guide, the small retail design guide, and the warehouse or self-storage design guide, and look at what the typical HVAC system types are across the country, you'll notice that, or realize that the typical HVAC system is a small package rooftop unit, and or a split system small unit. And so these are the typical systems used in these smaller buildings or warehouses around the country, and so recommendations are provided in each of these guides for these types of systems. For schools, on the other hand, typical systems vary significantly across the country. Small package rooftops are fairly common in California, for example. But in the northern climates, perhaps a chilled water VAV is the common system type, or unit ventilators. And water source heat pumps are fairly common in certain parts of the country. And so there's not one single typical system for schools. And so we provided recommendations in the schools design guide based on a range of system types, and we'll get into that a little bit more.
So the first guide that was done was the Advanced Energy Design Guide for small office buildings. It really focuses on office buildings up to 20,000 square feet. And a typical system for these types of buildings across the country, as Shanti just mentioned, was a split or single rooftop VX system. The guide does not apply to central plant systems. And we will talk more about this, but these guides are also tied into the LEED rating system from the U.S. Green Building Council. And it is an alternative path to get 4 energy and atmosphere credits. The second in the Advanced Energy Design Guide series, was the small retail buildings, also focusing on up to 20,000 square feet. You'll see a lot of similarities between these guides, and some of the major changes between them was how we handle the plug loads and the size of those plug loads. Split rooftop systems are discussed in this guide. Again, it does not apply to central systems. So you will see many of the same HVAC recommendations between those two guides. with very specific how-tos tailored to the retail marketplace.
So just to get a sense of where the energy savings are coming from in terms of about 30% savings based on the climate, for example, this is just an example of retail, one of the retail sets of recommendations. In Miami, there's a fair amount of savings, about half the savings coming from lighting, and then another half the savings from the cooling recommendations, or the HVAC recommendations related to, say, cooling efficiency and duct design and outdoor air control. In Baltimore, the savings are split over lighting recommendations, cooling recommendations, and heating recommendations. And in cold climates such as Davlit, climate zone 7, I believe, the majority of the savings come from envelope recommendations to reduce heating load, and then HVAC recommendations that reduce the heating load. So you can see that the energy savings over various climate zones relate to different types of recommendations, and we'll focus again on the heating and cooling recommendations to realize these savings over 30%.
One of the advantages of the guide over some previous work is that it really looks at the integration of systems. That these savings were based on whole building savings, so that when you start reducing your lighting loads, that also impacts your HVAC loads. And those savings were accounted for in this guide, and that interaction was taking place, which is one of the reasons that it's important on the design side to think about the envelope and the lighting first, and then design the HVAC to match whatever remaining loads that you have. So Shanti is going to discuss the HVAC recommendations at this time.
So for both the small office and the small retail, a lot of these recommendations are the same as Paul talked about. On the efficiency side, there are, for the air conditioners, there's a range of EER recommendations for various sizes of rooftops, from 0 to 65,000 BTUs per hour rooftop, to 65 to 135,000 BTUs per hour rooftop, and then 135 to 240. And so for each one of those sizes of rooftops, there's a different efficiency recommendation by climate zone. Again, gas furnaces have a range of efficiencies based on single package or a split system, and then again on heat pumps for a range of sizes. There are efficiency recommendations. Here's an example of the cooling efficiencies that are contained in the guide. You'll see the range of sizes of rooftops or split systems for the air conditioners based on SEER or EER from climate zone 1 through climate zone 8. This table shows the range and how the recommendations vary over the climate zones. In general, the cooling efficiencies were generally higher in the hotter climate zones and lower in the colder climate zones. For the smallest rooftop or air conditioners, the ones from 0 to 65,000 BTUs per hour, there's a 13 SEER recommendation for all climate zones, and this is basically the highest efficiency available from multiple manufacturers. For the larger systems, the efficiencies are higher in climate zones 1 than, say, climate zone 5, and when there's NR, which refers to no recommendation, that refers to using the code minimum efficiency for that system type. And so these are the recommendations in the small office design guide and the small retail design guide.
I think now's a good time to interject that all of these recommendations are also documented in technical reports that either the National Renewable Energy Lab or Pacific Northwest National Lab put together and as technical support documents. Those technical support documents are also on the ASHRAE website, and many of the assumptions and additional questions about how these results were achieved can be found in those support documents. And like I said, they are also available on the ASHRAE website, as well as the download of these guides.
So now if we look at the heating efficiencies contained in the small office and small retail, again, the heating efficiencies are generally higher in the colder climates and then lower in the warmer climates. You'll see for the gas furnace efficiencies for a split system as well as a single package, or the BSP abbreviation there. the recommendations vary or are consistent across for the smaller systems, or the 0 to 225,000 kV2 per hour system, at 80%. The idea here is that there's concerns when you have a system that's outside and freezing with the condensation. So 80% is the maximum that was available for multiple manufacturers on the heating efficiency for some of the furnace systems. For the split system, there are higher efficiencies available, and those are recommended in the colder climate zones, climate zone 5 through 8, and you'll see that in the split system recommendations for the small office and small retail design guide. And finally, the heat pump recommendations are shown for climate zones 1 through 8, based on EER and COP on the heating side. Some of the additional pieces of the HVAC design, focusing on economizers. Economizers are recommended for both the small office and small retail design guide in climate zones 3 through 6, boarding system greater than 54,000 BTUs per hour. This is a slightly smaller systems that they're recommended than code, and that economizers are not recommended in climate zones 1, 2, and then 7 and 8. Outdoor air is controlled based on CO2 for all climate zones, for both the small office and small retail. And there's also various recommendations for interior duct design, 0.08 inches per 100 foot of ductwork. You can see an example of what that table looks like in each of the design guides below here. For ventilation control, a motorized damper is recommended. Again, demand control ventilation, and then details on duct design for each climate zone are provided.
As we've shown here, it is important to look at the whole system and not just the device that's providing the heating and cooling and moving that air. But we really wanted to try to start getting at duct design, especially in a building sector where ductwork is not usually well thought out. And so there are how-to tips on dealing with takeoff and using gentle elbows, etc., as well as encouraging right-sizing the ductwork so that you can reduce some of your airflow rates and reduce those frictional losses along the duct. As far as the how to implement, which goes to Chapter 5, this really looks at good design practice for office and retail spaces, looking at humidity control at part load, looking at energy recovery, bypass dampers, ventilation and air configuration, ductwork distribution, duct insulation and sealing, as well as control strategies to turn off the equipment. It also gives some cautions in terms of release fans or dampers rather than return fans, noise control, as well as recommendations for where to locate carbon dioxide sensors. As far as the LEED new construction, energy and atmosphere credit and optimizing energy performance, this provides a second option that additional simulation is not used. If you can go through these recommendations and check that you have complied with all those recommendations, then you get 4 EA credits. And that applies for prescriptive measures for both the small office and the small retail buildings. There are some restrictions that apply which really just fall under the guidance of the Advanced Energy Design Guide. One is that the buildings must be under 20,000 square feet. They must be office or retail occupancy, depending on which guides you're using. And the project teams must fully comply with all the applicable recommendations as established in the Advanced Energy Design Guide for the climate zones in which the building is located. In fact, if you look at the later guides, one of the improvements to the table that was made was an area to actually check off the box. So you literally can check those boxes off, and when all has been met, you will get the 4 credits in this section of LEED. The Advanced Energy Design Guide for warehouses and self-storage was the 4th in the series. We're going to leave the schools for a little bit later because that is a little bit more complicated. It focuses on small warehouses up to 50,000 square feet in self-storage. where the main HVAC system is a split or single package rooftop DX system. It does not apply to buildings that use central plant systems. You'll notice that there's many similarities between this guide and the other two guides in terms of the HVAC recommendations. There are some very specific warehouse additions. Those additional recommendations include the cooling system type in the conditioned storage spaces, looking at variable speed fan and compressor heat pumps for zones 1 through 6, and maintaining humidity control at part load. It also requires a higher efficiency furnace in zones 5 through 8. One of the big differences on this guide is to use destratification fans in the high base spaces, and there are specific how-to tips and explanations about those fans. There are also no demand-controlled ventilation recommendations in this section.
So there's additional how to implement recommendations as well that are related to specific designs of warehouses. There are how to implement recommendations for things such as indirect gas-fired unit heaters, recommendations for radiant slab design in spaces that have high infiltration rates, such as loading docks, ventilation rates that can be determined based on product storage off-gassing rather than outdoor air requirements for people, as well as low leakage recommendations and design guidance for automatic louver dampers on exhaust fans that in spaces that are not air conditioned, and to attempt to minimize the heating season infiltration.
As we move into schools, one of the things that became very obvious with schools, especially compared to some of the other guides, is that schools vary widely based on elementary, middle, and high school in terms of what their functionality is and what some of the specialty spaces are in each of those. In addition, and specifically related to HVAC, that HVAC design is very regional with these, and we try to account for different system types in these buildings. And so you'll see that the tables in the K-12 school are much larger than what we found in the other design guides. We divided these solutions into typical space types, realizing that they also have specific needs in these buildings. Those space types included classrooms, administrative, corridors, restrooms, and then gyms, assembly areas, kitchen, and media centers. There are some spaces that were not covered in this guide because they were considered too much specialty and were not necessarily widespread use through the nation. Those included spaces like pools, wet labs, woodworking and auto shops, as well as sports field lighting. Shanti's going to talk about some of the modeling results. This graph is definitely has a lot of information on it, but it also kind of gives you an indication of the type of analysis that was done for the school. But this type of analysis was also done for the other advanced energy design guides.
So this is an example of some of the results for a specific Davlit elementary school, and showing the savings, the range of savings, over 30% for climate zones 1 through climate zones 8, with the humidity variations in whether they're humid climate zones, dry climate zones, which are the B climate zones, or marine climate zones, which are the C climate zones. This graph shows for each of those climate zones and subclimate zones the baseline and uses, as well as the various savings for each of the recommendations for Davlit, for a package single zone recommendation, a VAV recommendation, and a package VAV recommendation. So there's a wide range of ways to show the savings, and there's multiple pathways that the guide presents to reach those savings. There's also an equivalent graph. If daylighting was not possible in your school, there's non-Davlit recommendations for the various HVAC systems.
It is important to note that, and it was discussed elsewhere, that daylighting, this is the only guide that has a path specific for daylighting, and the result is some differences on the HVAC side based on daylighting strategies in terms of sizing. There are recommendations for 6 different HVAC types for the school. Those are single-zone package DX systems, water source, which can also include ground source heat pumps with a dedicated outdoor air system, unit ventilators with chilled water in a boiler, fan coils with chilled water and a boiler with a dedicated outside air system, as well as multiple zone VAV package DX rooftop units and multiple zone VAV air handlers with a water chiller. Here's an example of the recommendation table for the K-12 schools, and you can see that the different HVAC types are listed in the first column. Under each one of those, it has unique recommendations for each HVAC system. There's one of these tables for each of the different climate zones. This particular table is from climate zone 2, and the highlighted area would be for a water source heat pump, showing the different sizes of the components, as well as the recommendations in terms of COPs and EERs, and then finally the how-to tips, showing where you can go for more information about each of these pieces. And as I mentioned before, there's a little checkbox on the right-hand side, and you can use that checkbox to kind of guide you through the process and see how you're doing in order to get any energy and atmosphere credits and complying with the guide. As far as the HVAC equipment efficiencies, these recommended efficiencies are based on the climate zone, the HVAC system type, the size of that system, as well as the fuel type. The guides were restricted to either electricity or natural gas as the fuel types that are available on the site. The table at the bottom is for climate zone 5, and it's an example showing package DX rooftops or DX split systems. Again, showing the different sizes in the second column, as well as then the recommendation for the SEERs or EERs or COPs, and for furnaces, the annual fuel utilization efficiency.
So if you look at Chapter 5 of the school's Advanced Energy Design Guide, there's a fair amount of detailed good design practice how-to tips that are contained in Chapter 5, and each one of these are shown here on this slide. The ones highlighted in blue are ones we'll talk about in some detail, just because these are some of the more important concepts that are provided in the good design practice section. The first one is HV11, which refers to ventilation air. They're good design practice recommendations based on how to size your outdoor air system, and one of those is to use the actual occupancy of the school for your outdoor air calculations and not the egress or exit population to size your outdoor air system. Another good design practice is to use population diversity when sizing a multiple zone system, as well as using time-of-day schedules to introduce ventilation air only when a zone is expected to be occupied. It's a fairly basic way to do demand control ventilation based on time of day and expected occupancy, and it's kind of the baseline standard recommendation for all HVAC systems provided in the school's design guide for ventilation control. Here's an example for a package DX rooftop system type. There are ventilation recommendations for every single system type, and for this case, you'll see here that ventilation, the recommendation for control is either through demand control, which would be a CO2 sensor, or energy recovery. The idea is that reducing ventilation outdoor air loads can be done through either mechanism, demand control ventilation or energy recovery ventilators. The idea here is that some system types lend themselves to better due to demand control ventilation, and other system types, such as the bigger central outdoor air systems, such as the VAV systems, lend themselves better to energy recovery. And so we provided some flexibility in handling ventilation efficiently.
Again, I think we need to reiterate that all of these recommendations were based in simulation and vetted through a committee of experts that design, in this case, schools very specifically, and that it was felt that these recommendations could be readily adopted by schools.
Another important good design practice provided in the school's design guide is part load dehumidification. There are strategies provided to minimize cycling of constant speed fans. Is the primary concept here. The idea is to design a system to minimize the number of hours that space relative humidity remains above 60%. And there are recommendations, or there are recommended methods for improving the part load dehumidification for various HVAC system types. One of those recommended system types, or ways to reduce part load dehumidification, is a dedicated outdoor air system, which is recommended for the water source heat pump system type, the fan coil system type, as well as an option for unit ventilators. Another important concept is sizing, or is how you zone the spaces and connect them to the central or the central HVAC systems. The idea is to divide your building into thermal zones based on building size, the orientation, the layout, and the function, as well as the after-use requirements. For the multiple zone systems, there are recommendations for avoiding using a single air handler that serves zones with significantly different occupancy patterns. You'll want to provide a single air system for the gym and a classroom, mostly because those occupancy patterns are usually significantly different, and there's savings to be had for systems that can provide heating, cooling, and ventilation to each one of those zones as needed. And another important design tip is maintenance. Schools are notorious for neglecting maintenance programs, and a preventative maintenance practice can quickly negate neglecting preventative maintenance practices can quickly negate any energy savings expected. Things such as filters, ERVs checked and cleaned, dampers, valves, louvers, sensors must all be periodically inspected and calibrated, especially when it comes to CO2 sensors, as well as the asset management strategies, being able to manage your utility bills and verifying energy savings are continued and sustained.
We can't stress enough the ability to design systems that are relatively simple and design systems for maintenance. Shanti and I once looked at a school building that had an energy recovery ventilator, and it took us 2 hours to kind of get ourselves into the room and in the right position to remove the filters in this unit. And when we removed those filters, you can kind of anticipate the results, that they were quite dirty and were not terribly effective in helping that equipment operate. And so it's very important to plan for maintenance, have appropriate maintenance documents. The other thing that is often forgotten in schools, because schools last a very long time, you can pretty well guarantee that that equipment will be replaced, and that the design needs to account for being able to replace that equipment without doing things such as peeling off the roof of the building. And so plan for maintenance, because the building will way outlive the life of the equipment. The energy and atmosphere credit for optimizing energy performance is a little bit different. It again provides a prescriptive compliance path for LEED, offering up to 4 credits, or offering 4 credits. In order to do that, you need to comply with the prescriptive measures of the Advanced Energy Design Guide for K-12 schools. And there are some restrictions that apply. Those restrictions are that the buildings must be under 100,000 square feet. We realize that probably excludes many high schools that are built today. Buildings must also include typical spaces covered under the scope of the guide, and the project teams must fully comply with all applicable recommendations as established in the Advanced Energy Design Guide for the climate zone in which the school is located. There are some future guides coming along. The Advanced Energy Design Guide for Highway Lodging has just completed the 90% review and should be available for publication this fall. Again, it will be available as a download from the website. Just out of the starting blocks is the Advanced Energy Design Guide for healthcare facilities, in particular looking at smaller healthcare facilities. This does not include large, complicated hospitals. And there are several others that are planned in the 50% level, which include K-12 schools, big box retail, small office, and small retail. This is kind of the next step after getting to the 30% design guide. And again, these guides are all available for download at the ASHRAE website, ashrae.org/AEDG. And many of the technical questions can be handled through the technical support documents, which are also available on that website. Shanti and I would like to thank you for your attention to the formal part of this presentation, and this concludes the presentation. And I do believe we have some time available for answering some questions.
Well, thank you very much for an informative webcast, Paul and Shanti, and thanks to all of you. The U.S. Department of Energy appreciates your attendance today.